Hello students, welcome all of you. In this video, I Abhay Kumar going to solve the problems of the book Concepts of Physics written by Dr. S.C. Verma of chapter 6 Friction from problems number 6 to 8 for class 11 physics, IIT JEE and NEET entrances. First of all, problem 6. A body of mass 2 kg is lying on a rough inclined plane of inclination 30 degree. Find the magnitude of the force parallel to the incline needed to make the block move part A up the incline and part B down the incline. Coefficient of static friction mu s is equal to 0.2. एक रफ इंक्लाइन प्लेन है, झुका हुआ तल है हॉरिजेंटल से 30 डिग्री के एंगल पर, जिस पर कि 2 kg मास का ऑब्जेक्ट लाई करता है, सिचुएटेड है। तो उस ब्लॉक को, उस बॉडी को जिसका मास 2 kg है, उसे इंक्लाइंड प्लेन के पैरेलल और इंक्लाइन के पैरेलल ऊपर की ओर अपवर्ड डायरेक्शन में मूव करने के लिए जितना फोर्स अप्लाई करना होगा उसका मैग्नीट्यूड मालूम करना है, फाइंड करना है। और पार्ट बी में उस ब्लॉक को इंक्लाइन प्लेन पर नीचे की ओर मूव कराने के लिए कितना एक्सटर्नल फोर्स अप्लाई करना होगा उसे भी कैलकुलेट करना है। नाउ वी हैव टू सॉल्व इट। कोफिशिएंट ऑफ फ्रिक्शन, स्टैटिक फ्रिक्शन बिटवीन द ब्लॉक एंड द रफ इंक्लाइन प्लेन इज 0.2. नाउ mass of the block capital M is equal to 2 kg and inclination of the inclined plane, that is angle which the inclined plane AB makes with the horizontal bx is 30 डिग्री। इंक्लाइन प्लेन का हॉरिजेंटल से इंक्लिनेशन 30 डिग्री है, थीटा इज इक्वल टू 30 डिग्री। तो फर्स्ट ऑफ ऑल सॉल्यूशन ऑफ पार्ट ए, मैग्नीट्यूड ऑफ द फोर्स पैरेलल टू द इंक्लाइन to move the block, this block, suppose it is B, upward, in upward direction, along the incline in the upward direction is given by P is equal to 2g mg sin theta. Here mass of the body is 2 kg, so 2g sin theta is 30 degree plus frictional force F. This is the force, magnitude of force which is needed to move the block B parallel to the incline in the upward direction with uniform velocity, that is with zero acceleration. So that force, upward force along the incline is P is equal to 2g sin 30 plus F. F is the friction force frictional force acting between the block B and the inclined plane equals to 2g sin 30 degree plus Fk is equal to mu into n, that is coefficient of friction. Here coefficient of a static friction is given 0.2. So mu s is given here. So mu s into n, frictional force is mu s into n, and n is balanced by, what is n? N is the normal reaction of the inclined plane. Inclined plane is AB in the diagram, and weight of the block acting vertically downward along OD direction, that is mg, that is 2 into g, and one component of weight, that is 2g, that is vertical component of the weight 2g cos 30 balances the is balanced by the normal reaction of the inclined plane, that is n. So normal reaction n balances the vertical component of the weight 2g cos 30. So mu into n, and n is 2g cos 30. So the body is in vertical equilibrium. वर्टिकल डायरेक्शन में इंक्लाइन प्लेन के परपेंडिकुलर अपवर्ड डायरेक्शन में नॉर्मल रिएक्शन है और डाउनवर्ड डायरेक्शन में इंक्लाइन प्लेन के परपेंडिकुलर ही वेट का वर्टिकल कंपोनेंट 2g cos 30 है, जो एक दूसरे को बैलेंस कर देते हैं, इसलिए यह बॉडी वर्टिकल इक्विलिब्रियम में है। तो केवल हॉरिजॉन्टल डायरेक्शन में, अपवर्ड डायरेक्शन में फोर्स सपोज किया जाए, फोर्स P अप्लाई किया गया है। लेट P बी द फोर्स पैरेलल टू द इंक्लाइन इन द अपवर्ड डायरेक्शन which will move the body block in the upward direction parallel to the plane. So let P be the force, that force, magnitude of force which we have to calculate. We have to calculate the value of magnitude of force, upward force P parallel to the incline. So along the inclined plane, only forces in the horizontal direction, that is P along upward direction, and 2g sin 30 is the another component of weight, that is horizontal component of weight of the block of mass 2 kg, that is 2g sin 30 along the incline in the downward direction, and frictional force between the inclined plane and block is also acting in the downward direction along the incline. So the force parallel to the incline needed to move the body in the upward direction is P is equal to 2g sin 30 degree plus F, and F is the frictional force acting between the block and the inclined plane, which is given by mu s into n, and n is balanced by 2g cos 30. So in place of n we can write 2g cos 30. Normal reaction of the inclined plane को हम के जगह पर 2g cos 30 रिप्लेस किया जा सकता है। तो इट इज P is equal to 2g sin 30 degree plus mu s multiplied by 2g into cos 30. 2g is common in both terms. 2g दोनों टर्म्स में कॉमन है, इसलिए hence we have 2g is taken outside the bracket. So 2g under bracket sin 30 under bracket plus mu s, coefficient of static friction between the block and the inclined plane is given. Mu s is 0.2. So in place of mu s we can write 0.2 into 2g cos 30. 2g into cos 30 is root 3 by 2. We can replace cos 30 by root 3 by 2 and sin 30 by 1 by 2. Value of sin 30 is 1 by 2. So it is 2 into g is equal to 9.8 under bracket 0.2 into 2, that is 0.4g into root under 3. So we have LCM is 2. So we have since 2g is taken out from the bracket, so inside the bracket it is only cos 30, which is root under 3 by 2. So in the above term P is equal to 2g sin 30 plus mu s into 2g into cos 30, and in the next term it is 2g is taken out of the bracket, so inside the bracket it is sin 30 is half plus mu s, the value of mu s is 0.2, coefficient of static friction, multiplied by 2g is taken out of the bracket, so it is cos 30 is root 3 by 2. It is root 3 by 2 now. Bracket is closed. Now LCM inside the bracket is 1 by 2 plus 0.2 into 0.3 upon 2, that is LCM is 2. So in the numerator inside the bracket के अंदर न्यूमरेटर में 1 प्लस 2 से 2 में डिवाइड करने पर 1 मल्टीप्लाइड बाई 1 इज 1 इन प्लस 0.2 मल्टीप्लाइड बाई रूट 3 इज 1.732. We can write it as 1.73. So now 2 in the denominator and numerator will cancel out. So we have P is equal to, that is force needed, magnitude of force needed to make the block move up the incline is P is equal to 9.8 multiplied by under bracket 1 plus 0.2 into 1.73, that is under bracket 1 plus 0.2 multiplied by 1.73 is 0.346. So we have P is equal to 9.8 multiplied by 1 under bracket 1 plus 0.346, or P equals to 9.8 multiplied by 1.346, and it is and it is now final result is now 9.8 multiplied by 1.346. We can write it as 1.35. After rounding off to two places after the decimal, it is 9.8 multiplied by 1.35. So the final result, the force, upward force along the inclined needed to move the body up is P is equal to, if we multiply 9.1 into 1.35, we will get 13.2 Newton. Answer. Now we have to solve problem 7 of chapter 6, friction, of the book Concepts of Physics. The problem is repeat part A of problem number 6, that is previous problem. If the push is applied horizontally and not parallel to the incline, calculate the magnitude of force. In the above problem, mass of the body was mass of the body or block lying on the rough inclined plane, making angle theta, making angle 30 degree with the horizontal, was 2 kg, mass of the block 2 kg, and coefficient of static friction between the block and the inclined plane is 0.2, and inclination, that is the angle which the inclined plane AC makes with the horizontal CX is 30 degree. तो प्रॉब्लम नंबर 6 में ब्लॉक का मास जो इंक्लाइन प्लेन पर, रफ इंक्लाइन प्लेन पर ब्लॉक सिचुएटेड था, उसका मास 2 kg था, और इंक्लिनेशन इंक्लाइन प्लेन का हॉरिजॉन्टल से 30 डिग्री था, और कोफिशिएंट ऑफ स्टैटिक फ्रिक्शन बिटवीन द ब्लॉक एंड द इंक्लाइन प्लेन AC was given 0.2. But in this case, the force P, suppose that force is P, which is applied along the horizontal, that is parallel to the horizontal surface, not upward along the inclined plane. This is the difference between this problem number 7 and the previous problem 6. इस प्रॉब्लम में ब्लॉक B पर फोर्स अप्लाई किया जा रहा है हॉरिजॉन्टल डायरेक्शन में, जो कि हॉरिजॉन्टल सरफेस CX के पैरेलल है, इंक्लाइन प्लेन के पैरेलल नहीं है. तो उस सिचुएशन में सपोज किया जाए कि मैग्नीट्यूड ऑफ फोर्स P है, जो कि ब्लॉक पर हॉरिजॉन्टल डायरेक्शन में एक्ट करता है. तो अब इस फोर्स का इंक्लाइन प्लेन के डायरेक्शन के साथ जो एंगल फॉर्म होगा वो अभी 30 डिग्री होगा, इसलिए कि इंक्लाइन प्लेन AC का हॉरिजॉन्टल से इंक्लिनेशन 30 डिग्री है. इसलिए फ्रॉम द ज्योमेट्री दिस एंगल, दैट इज द एंगल विच द डायरेक्शन ऑफ फोर्स P, which is the horizontal force parallel to the horizontal surface, will also make angle 30 degree with the inclined plane from the geometry. So we have to take two perpendicular components of this force P. One component P cos 30 along the incline, along parallel to the inclined plane in the upward direction, and other vertical component of the horizontal force P acting on the block is P sin 30 along the vertical component of the weight 2g, because mass of the block is 2 kg. It was 2 kg in problem number 6. So vertical component of the weight acting vertically downward along OD direction, while normal reaction of the inclined plane acts vertically upward along OE, and this normal reaction balances the vertical component of the weight of the block 2g, that is 2 cos 30, and now in this case another additional force P sin 30, which is the vertical component of the horizontal force applied on the body. So in this situation, n normal reaction of the inclined plane AC will balance the sum of two forces P sin 30 plus 2g cos 30. So we have normal reaction in this case is for the vertical equilibrium of the block ऑन द रफ इंक्लाइन प्लेन, रफ इंक्लाइन प्लेन AC पर ब्लॉक के वर्टिकल इक्विलिब्रियम के लिए नॉर्मल रिएक्शन जो इंक्लाइन प्लेन का है N will balance the sum of two forces, that is P sin 30, that is vertical component of the horizontal force P, vertical horizontal force ब्लॉक P पर जो इस प्रॉब्लम में दिया गया है, तो उसका वर्टिकल कंपोनेंट P sin 30 है, जो कि 2G cos 30 के लॉन्ग इंक्लाइन प्लेन के परपेंडिकुलर OH डायरेक्शन में नॉर्मल रिएक्शन के अगेंस्ट एक्ट कर रहा है. So normal reaction of the inclined plane will balance sum of two forces for the vertical equilibrium of the block P sin 30 degree plus 2G cos 30. Let this is equation number 1. It is normal reaction of the inclined plane on the block. Now to move the body up parallel to the incline in the upward direction, one component of the horizontal force P, that is P cos 30 degree, P cos 30 degree will be that force which will move the block upward parallel to the incline with uniform velocity without acceleration. So for upward motion of the block with uniform velocity without acceleration, with no acceleration, that is acceleration is equal to 0, will be P cos 30 degree equals to 2G sin 30 degree plus F, where F is the frictional force acting between the block and the inclined plane. जहाँ small f block B जो कि inclined plane AB पर AC पर situated है, लाई करता है, तो ब्लॉक तथा inclined plane के बीच frictional force है, and F is equal to mu into N we know, और P cos 30 degree equals to 2G sin 30 degree plus F equals to mu into, here mu is mu s coefficient of static friction given in the problem. So it is mu s into N multiplied by N, or N can be replaced by equation 1, normal reaction equal to P sin 30 degree plus 2G cos 30. So P cos 30 degree is the one of the component of the force acting parallel to the incline, which will move the body up parallel to the incline with uniform velocity, with zero acceleration, without acceleration. So P cos 30 is equal to 2G sin 30 degree plus mu s multiplied by N. In place of N, normal reaction, we can write from equation 1 P sin 30 plus 2G cos 30. So under bracket, in place of N, we can write P sin 30 degree plus 2G cos 30 degree under bracket closed, or P cos 30 degree, which is root 3 by 2. So it is P into root 3 by 2 equals to 2 into G sin 30, that is 2G sin 30 is half plus mu s into P into sin 30, mu s into P. अब ब्रैकेट को अगर रिमूव करते हैं तो mu s into P sin 30 is half plus mu s into 2G into cos 30. So it is mu s multiplied by 2G into cos 30 is root 3 by 2. We have to calculate the external force, magnitude of the force P. So it is P into root 3 by 2 minus, अब RHS में टर्म है mu s into P by 2, mu s into P into 1 by 2 sin 30 is half, तो उसे LHS में लाया जाए. This term is taken to the LHS from RHS, so the term will be negative in LHS. So it is P into root 3 by 2 minus mu s is 0.2 multiplied by P into 1 by 2, that is P by 2 equals to, in RHS it is 2 and 2 will cancel out in the first term of RHS, numerator and denominator दोनों में 2 प्रेजेंट है, दोनों कैंसिल हो जाएगा, तो इट इज ओनली G, फर्स्ट टर्म में G प्लस लास्ट टर्म में भी 2G से 2G का 2 और न्यूमरेटर में एंड डिनोमिनेटर में भी 2 है, कैंसिल हो जाएगा. तो in the last term also numerator in the numerator and denominator and in the denominator 2 will cancel out. So we have P into root 3 by 2 minus म्यू एस दैट इज 0.2 मल्टीप्लाइड बाई पी बाई 2, इस टर्म को LHS में लाया गया तो ये निगेटिव हो गया, इजकल टू फर्स्ट टर्म में जी बचा, 2 से 2 कैंसिल हो जाएगा, हुआ न्यूमरेटर डिनोमिनेटर में, एंड लास्ट टर्म इज, यहाँ पर भी न्यूमरेटर डिनोमिनेटर में टर्म 2 कैंसिल हुआ, तो इट इज म्यू एस इंटू जी इंटू √3. सो इट इज लास्ट टर्म इज म्यू एस इज 0.2 मल्टीप्लाइड बाई जी इंटू √3. नाउ वी हैव इन LHS p by 2, p इंटू √3/2, और यहाँ पर भी 0.2 इंटू p/2. सो 2 LCM हो जाएगा इस टर्म में, और p भी कॉमन हो जाएगा. सो इट इज p/2 रूट अंडर √3 माइनस 0.2 इक्वल्स टू इन RHS जी यहाँ कॉमन हो जाएगा, दोनों टर्म में जी प्रेजेंट है, तो जी अंडर ब्रैकेट 1 प्लस 0.2 मल्टीप्लाइड बाई रूट अंडर 3. And now in LHS we have p/2 in place, p/2 under bracket √3. In place of √3 we can write 1.73. So we have p/2 under bracket √3 is replaced by 1.73 minus 0.2, and in RHS it is g is 9.8 under bracket 1 plus 0.2 into √3 is 1.73, bracket is closed. और p/2 अंडर ब्रैकेट, अब 1.73 माइनस 0.2, तो 1.73 में से 0.2 माइनस करने पर p/2 मल्टीप्लाइड बाई 1.53 इक्वल्स टू 9.8 in the RHS. 9.8 multiplied by 1 plus under bracket 1 plus 0.2 into 1.73 is 0.346, और p multiplied by 1.53 upon 2 equals to 9.8 multiplied by 1.3, 1 plus 0.346, that is 1.346, that is it is in RHS it is 1.346. After rounding off we can write it as, or in LHS next term is p into 1.346 in RHS. After rounding off we can write it as 1.35. So in LHS it is next term is p into 1.53 upon 2, it is 0. After dividing 1.53 by 2 it is 0.7, we can write it as 0.76. If we divide 1.53 by 2 it is 0.7 times, it is 14, 1, 3, that is now 6 times, 2, 13, 6 into 2 into 6 it is 12, that is 0.76. So in LHS p into 0.76 equals to 9.8 into 1.346, we can write it as 9.8 multiplied by 1.35, and in RHS now if we multiply 9.8 into 1.35 we have already obtained in the previous problem 13.2. Therefore external force applied on the block to move the body to move the body up in the upward direction of the plane while the force is acting horizontal, not parallel to the incline. So we have taken the component of force P cos 30. तो उस फोर्स का मैग्नीट्यूड जो ब्लॉक पर हॉरिजॉन्टल डायरेक्शन में एक्ट कर रहा है उसका वैल्यू P इक्वल टू 13.2 अपॉन 0.76, एंड इट इज 1320 upon 776, and it is now if we divide 1320 by 76 we can obtain the value of P as 17.5 Newton. Answer. So The magnitude of force is 17.5 Newton. This is the answer of this problem. Number 7. Now we have to solve problem 8, which is the last problem of this video. In a children park, an inclined plane is constructed with an angle of inclination 45 degree in the middle part as shown in figure 6E1 given in the book. Find the acceleration of a boy sliding on it if the friction coefficient between the cloth of the boy and the incline is 0.6 and acceleration due to gravity G is in this problem 10 meter per second square. It is given. एक चिल्ड्रन पार्क है जिसमें कि एक इंक्लाइन प्लेन जिसका इंक्लिनेशन 45 डिग्री है हॉरिजॉन्टल से कंस्ट्रक्टेड है मिडल पार्ट में. तो एक बॉय, एक लड़का उस इंक्लाइन प्लेन पर स्लाइड करता है. तो कोफिशिएंट ऑफ फ्रिक्शन इंक्लाइन प्लेन और उस बॉय के क्लॉथ के बीच 0.6 है, दैट इज म्यू इक्वल टू 0.6 एंड जी का वैल्यू 10 मीटर पर सेकेंड स्क्वायर है. तो उस बॉय का डाउनवर्ड एक्सेलेरेशन, स्लाइड करने का एक्सेलेरेशन फाइंड करना है, कैलकुलेट करना है. तो लेट ए बी द डाउनवर्ड एक्सेलेरेशन ऑफ द बॉय विच इज sliding on the inclined plane, rough inclined plane in the park, constructed in the park. So mu is given according to the problem. Mu is equal to 0.6 and g is equal to 10 meter per second square. Weight of the boy will act vertically downward, which is represented in figure 6E1, and normal reaction of the boy is perpendicular or normal to the inclined plane, which balances the vertical component of the boy, which is mg cos 45 degree. Other component of the weight of the boy is mg sin 45 degree along the incline in the downward direction, and frictional force acting between the boy and the inclined plane is a small f, which is mu into n, that is mu into mg cos 45 degree, which acts in the upward direction along the incline. Since the boy is since the boy sliding on the inclined plane is in vertical equilibrium, because normal reaction balances the vertical component of the weight mg cos 45 degree, vertical component of the weight of the boy. So n equals to mg cos 45 डिग्री, क्योंकि बॉय इंक्लाइन प्लेन पर जो कि डाउनवर्ड डायरेक्शन में स्लाइड कर रहा है चिल्ड्रन पार्क में, जो इंक्लाइन प्लेन कंस्ट्रक्टेड है उस पर, तो वह वर्टिकल इक्विलिब्रियम में है, इसलिए कि इंक्लाइन प्लेन का नॉर्मल रिएक्शन उसके वेट का कंपोनेंट, वर्टिकल कंपोनेंट mg cos 45 डिग्री को बैलेंस कर ले रहा है. इसलिए अब केवल हॉरिजॉन्टल डायरेक्शंस में ही फोर्सेस रिमेनिंग हैं, बचे हुए हैं, जो कि अप्लाइड है mg sin 45 डिग्री इंक्लाइन प्लेन के अलॉन्ग डाउनवर्ड डायरेक्शन में, जो कि उस बॉय को नीचे की ओर स्लाइड करने में हेल्प करेगा, और अपवर्ड डायरेक्शन में इंक्लाइन प्लेन के अलॉन्ग अपवर्ड डायरेक्शन में फ्रिक्शनल फोर्स उस बॉय के क्लॉथ तथा उस बॉय एंड इंक्लाइन प्लेन के बीच का जो फ्रिक्शनल फोर्स है वह अपवर्ड डायरेक्शन में एक्ट करेगा, जो कि बॉडी का जो कि बॉय का डाउनवर्ड डायरेक्शन में स्लाइड करने का या जो अप्लाइड फोर्स है mg साइन 45 डिग्री वेट का बॉय के वेट का अदर कंपोनेंट उसका अपोज करेगा. सो since n balances normal reaction of the inclined balances the component vertical component of the weight of the boy mg cos 45 degree. Suppose it is equation number 1. So the downward resultant force acting on the boy is, so the downward resultant force acting on the boy is F equals to capital F equals to mg sin 45 degree minus minus F. F is the frictional force acting between the boy and the inclined plane, and it is mg sin is equal to mg sin 45 degree minus F equals to mu into n, because force of friction is directly proportional to normal reaction. So we can write F equals to mu into n, or resultant downward force acting on the boy is mg sin 45 degree minus mu, and n is equal to mg cos 45 degree. N is equal to normal reaction of the inclined is balances the vertical component of the boy mg cos 45 degree. That is equation number 1. So in place of n we can write mg cos 45 degree, or mg can be taken out of the bracket because mg is present in both terms. Mg is common. So mg, we have mg under bracket sin 45 degree minus mu, and mu is given 0.6. So putting the value of mu, that is mu is equal to 0.6 and into cos 45 degree sin 45 degree. Mass of the body is not known, not given in the problem. So F equals to resultant force equals to mg. G is 9.8. In this problem G is given 10 meter per second square, but the standard value of G is 9.8. तो अगर किसी प्रॉब्लम में G का वैल्यू 10 दिया हो तो 10 पुट करेंगे, अदरवाइज 9.8 मीटर पर सेकेंड स्क्वायर. सो G is 10, so it is 10 m into 10 under bracket sin 45 degree is 1 by root 2 minus 0.6 multiplied by cos 45 is also 1 by root 2. Now root 2 is inside the bracket. Root 2 is LCM, or root 2 is also taken out. Then root 2 will also taken out of the bracket. So it is m into 10 upon root 2 under bracket 1 minus 0.6, and 1 minus 0.6 is 0.4. So it is capital M into 10 upon root 2. 10 meter per second square is the value of acceleration due to gravity. M into 10 upon root 2, and inside the bracket it is 1 minus 0.6, it is 0.4. This is the resultant force. This is equation number 2. Now we have to find the acceleration of the boy. From Newton's second law of motion, we know that acceleration is equal to force upon mass. So acceleration, downward acceleration of the boy during sliding over the rough inclined plane constructed in the children park is downward acceleration A is equal to force upon mass F upon m from Newton's second law of motion, and F is given in equation 2. We have already obtained F is equal to m multiplied by 10 multiplied by 0.4 upon root 2. This is the value of F upon m है तो multiplied by in the denominator it is capital M. M in the numerator and also in the denominator will cancel out. न्यूमरेटर तथा डिनोमिनेटर दोनों में m प्रेजेंट है, इसलिए दोनों कैंसिल हो गया. तो वी हैव नाउ वी हैव 10 into 10 upon root 2 multiplied by 0.4. So 10 multiplied by 0.4 is 4. That is 10 multiplied by 0.4 is 4 by 10. So 0 will cancel out. So 10 multiplied by 0.4 is only 4 by root 2. If we multiply numerator and denominator by root 2, then we have in the denominator it is root 2 into root 2, that is 2, that is 4 root 2. In the numerator it is 4 root 2, numerator में 4 root 2 और denominator में root 2 into root 2, that is 2. 4 will cancel out by 2, that is 2 times, that is 2 root 2. तो 4 2 से कैंसिल हो गया, तो आंसर 2√2. सो डाउनवर्ड एक्सेलरेशन ऑफ द बॉय इज 2√2 मीटर पर सेकेंड स्क्वायर. दिस इज आंसर ऑफ this problem. Acceleration of the boy is equal to 2√2 meter per second square. Now this video is completed. Thanks all of you for watching my YouTube channel.